Hello, everyone, and welcome to another video with Special Maths Academy. In this video, we'll be looking at the 21st problem from the 2023 Special Maths Contest. Okay, so let me just increase the thickness of my pen before we start here. So as you can see from this question, it says Super Eagles coach is tasked with carrying a squad of 23 men for the FIFA's World Cup tournament. This squad must consist of at least one goalkeeper, one defender, one midfielder, and one attacker. Given that the number of defenders must not be less than the number of midfielders, which also must not be less than the number of attackers, which also must not be less than the number of goalkeepers, how many possible squad formations are possible? Okay, yeah. So a possible formation would be two goalkeepers, eight defenders, seven midfielders, and six attackers. Okay. Interesting problem. Before we dive into this question, please don't forget to like, share, comment, subscribe, share with other Super Eagles fans. The sad thing is, since this question was proposed by the Special Maths Contest, um, the Super Eagles have not qualified for the World Cup. So hopefully that changes uh, the next 4 years. Okay, let's go into this question. So the first thing you'll notice is that we have an ordering. Okay, so basically, no need of like really reading whether it's defenders or midfielders or whatever. It's kind of we want to solve this question. So A plus B plus C plus D equals to 23. And it's not strictly ordered. So, okay. So something like this. Okay. So, one less than or equals to this. Okay. So if, if we relax this condition, right? We relax this condition and we just want to solve A plus B plus C plus D equals to 23. Okay. It translates to just a common problem of kilometers and boundaries. Okay, so we can interpret the question this way. So let's say we just want to solve this first. So let's try and solve this first. And we have A, B, C, D. They're all greater than 1. Okay, so a good way to solve this is we look at so we can say we can consider like 23 ones. Okay, so 23 ones. Then we look at the spaces, so 22 spaces. Okay. Now we want to pick three spaces. So and picking three spaces maps to one possible solution. Okay. So for instance, if I pick the first three spaces, so if I demarcate it 1, 2, 3, so this translates to 1 plus 1 plus 1 plus 20. Okay. So because there are 20 ones here left. Okay. Yeah. So it means we have 22 spaces and want to pick three. So this is just a classical combinatorial question. So this is going to be 22 combination 3. Okay. So that's let's just simplify it and have it written somewhere. So 22 times 21 times 20 divided by 3 times 2 times 1. Okay. So 3 will go into 21, 7. 2 will go into this 11. So I have 11 times 7 times 20. So that's going to be 1540. Okay. So 1540. So this is when we relax condition. And yeah, maybe some people might be unlucky and conclude here and then just pick option C, but that's not what the problem is asking us for. So we have to consider this condition. Now, the good thing is if I give you any four numbers, so if I give you, for instance, 1, 4, so these are just random numbers, 1, 4, 5, 3. Okay, so there's only one possible way to order them in ascending order. So this is one, it's going to be 1, 3, 4, 5. Okay. And even if maybe two of the numbers happen to be equal, so even if two of the numbers happen to be equal, there's only one possible way. Okay. So what does that tell us? It means we want to consider, subsets of this solution. So the first subset, we want to consider when exactly two are equal. So let's just call it S2. want to consider when exactly 3 are equal. Let's call it S3, and want to consider when exactly 4 are equal. Okay. So this will help us in accounting. So let me scroll down. So first of all, let's just look at S4. So I'll just eliminate it. S4. So if you have something like A plus A plus A plus A equals to 23. So we have 4 integers. 4A equals to 23. So here, A cannot be an integer because 23 divided by 4 is not an integer. Okay, so this gives us a contradiction. Okay. Now, S3. So what I want to point out here is that S3 is contained in S2. Okay. So if we have a tuple and 3 are equal, so it means 2 are equal. Okay. So it kind of satisfies that. So let's just count S2. Okay. And so the way I'm going to count it, right? So first of all, I want to count it where the order does not matter. Okay. So S2. So order does not matter. So that's how we're counting for now. Okay, order does not matter. So it means we have to avoid overcounting. So S2, if 2 happen to be equal, so let's say we have A plus B plus C equals to 23. Okay, so this is equivalent to A plus B plus 2C equals to 23. Okay, so now if we pick values of C from C equals 1 up to, okay, so how large can C be? Of course, C cannot be more than 11. So we pick values of C from C equals 1 to C11. So for instance, let's just look at one. We have A plus B equals to um, 23. So that A plus B plus 2 equals 23. So that's going to be A plus B equals 21. So they're exactly, so recall, order does not matter. So they're exactly 10 solutions to this. Okay. If saying order does not matter. So basically, we can have 1 plus 20. So A can go from 1 to 20. So 20 plus 1. So the reason why it's not 20 solutions and it's 10 solutions because we're trying to avoid overcounting. So um A, so 1 plus 20 basically, and 20 plus 1 are the same thing. So we just divide by 2. So this next one, 2 plus that would be 2 plus 19 and 19 plus 2, the same thing. So that's why we have 10 solutions. And we do this for each value of C, each possible value of C. Okay, so let me erase this. So we have 10 solutions. So basically, so C equals 1, 10 possible solutions, 10 possibilities. And then if C is equals to 2, so C equals 2, we have A plus B plus 4, so it is going to be 19. Once again, we'll just have, so basically 9 solutions and so on and so forth up until 1. So basically what I'm trying to say is S2 is going to be, so 1 plus 2 plus 3 plus up to 10. So that is 10 plus 1 divided by 2 times 10. So we have S2 is going to be 55 solutions. Okay. 55 solutions. So take note of that number, very important. Okay, so now let's look at S3. So recall that we don't want the order to matter. So order does not matter. So for now, order does not matter. And the reason why I'm saying order does not matter is because remember I said that S3 is contained. So this sign, this symbol here means contained. S3 is contained in S2. Okay. So we need to remove S3 from S2 first of all. Then before we not say, okay, let's now see the total possibilities when we account for the order. So S3, so we have A plus B plus B plus B equals to 23. Okay, so we have A plus 3B equals to 23. Okay, so we know that B can range from 1 to 7. Okay, because if B is greater than 7, then it's going to be greater than 23, and we don't want that. So B can range from 1 to 7. Okay, so it means there are 7 possibilities here. Okay, so we don't have to start considering, overcounting and stuff like that because it's only one free variable. So it fixes. So once we pick B, it fixes A. Okay. So now we have seven possibilities. So we have that S3, we have seven, where order does not matter. Okay. So now it means, so let me bring in a new, so S2. So let me put, okay, let me, how will I do this? So, uh, okay, let me use the symbol M, or let me use E. Yeah. So let E2. So E2 is a set, so where only two. So exactly two. So E for equal and E for exactly. So if E2 is a set where exactly two numbers are equal, then without order, so without order, when order is not considered, without considering order, the size of E2 is just going to be 55 minus 7. Okay. So 55 minus 7, that's equal to 48. Okay, so take note of that. So we have 7, we have 48. So now let's go back to, so recall, we have 1540. Okay. So now let's define more sets. So E0, so let E0 be no equality. Okay. Okay. No equality. So now, if we consider order, okay, so it means 1540, the out universal set, 1540 is equals to 20. Okay, so I'm not right. So it's equal to 4 factorial times E0. So this is exactly when there's no equality, plus, so if so S3, so I just E3 is equals to S3. So exactly 3. So because S4 is 0, that's why we can just, so record that without order. So so this implies E3 is equals to S3. Okay. So we have 1540 is going to be equal to 4 factorial times E0 plus, so E2, how many ways can, so if I consider the order, how many ways can that, take place? So record that we have the first, so if we have A, B, C, C, so we have four spaces. So the first number, so we'll fix the C later, fix the C last. So the first number has four possibilities, four spaces to pick from. So it can be here, here, or here. Then the second one, B, will have three possibilities. And once we fix A and B, C just occupies the remaining spaces left. Okay. So that's going to be 4 times 3 times E2. Okay. So record that E2 is 48. And then E3. So E3 is, so if we have, is going to be A, B, B. So just have to fix A. So only 4 ways. So 4 times E3. Okay. So 1540 is equals to 24 E0. So recall, we want to find that E0 plus 12 times 48 plus 4 times 7. Okay, so let me scroll down. So 1540 equals to 24 E0 plus, so 12 times 48. So 2 times 48 is going to be 96. 1 times 48, just 48, so this is 6. 7 carry 1. We have 576. And plus, so 4 times 7 is just 28. So now I have 576 plus 28. So 8 plus 6, 4, 0, so 640, 604. So 1540 is equals to 24E0 plus 604. So it means 24E0 is equals to, so 1540 minus 604. So it's going to be 36,936. Okay, and then so E0 is going to be equals to, so 936 divided by 24. So 93 divided by 24. So that's going to be, we have 3 remainder 21. So then 216. Okay, so 24 will go into 216. This will go into this 4. This will go into this 36. 4 will go into this. Okay, nice. So E0 is 39. Okay. So 39. So E0 is 39. So what does it tell us? It means when there's no equality, we have exactly 39 ways. Okay. So now recall that we're interested in solving this special problem. Okay. The special problem on the left. So now this special problem on the left is going to be equals to E0 plus E1, rather E2, which should be 2, E2 plus E3. Okay, so why? So recall that I said that every tuple, so when you consider the general solution, okay, that's the general one, this is on the right, every tuple has exactly one way to be ordered in ascending order. Okay. So now that's why so you see that the E0, E2, and E3, these are like the sets that we did not consider order. So this is 39, okay, plus so E2 48 plus 7. Okay, so it's going to be equal to 55 plus 39. So that is going to be 94. Okay. So 94 ways to have A plus B plus C plus D to be 23. 1 to be less than or equals to A to be less than or equals to B to be less than or equals to C to be less than or equals to D. Okay. So I hope you've learned something new. In the description, I'm going to link a video that's similar to this. So it was also a counting problem, and that one I explained more concepts. Okay, so this one, as you can see, I solved it in I would say a more common sense way. Okay, but the video I'm going to link in the description, I solved it in a more rigorous way. So we discussed inclusion exclusion principle and things like that. So don't forget to like, share, comment, and subscribe, and see you in the next video. And I hope the Super Eagles qualify for the next World Cup. So that's not 2026 World Cup, so maybe 2030 World Cup. Goodbye, everyone. See you in the next video. Bye.